Hello, this is Rafeeq. Today we'll talk about data structures in Java. So let's start by defining what is data structures or what the data structures are. So the data structure is a collection of related data that we can store, process, access, manipulate, and do more operations on the data that we are saving in the data structure. So we have different data structures in Java, and such an example, we have lists, stacks, queues, and much more. So in this video, we'll talk about the list initially, and then we'll talk about some of the operations that we can do on the list plus the collections class, and we'll talk about the collection framework or Java collection framework. So this is the hierarchy for Java collection framework. So in Java, we have different data structures, and here in this slide, you can see the data structures, and you can see the Java collection, where the collection is a container that can save different objects. So at the top of this hierarchy, we have the collection interface. So we have here in this collection, we have some, in this Java collection framework, we have some interfaces, abstract classes, and concrete classes. And this is a great example for representing and using the interfaces and abstract classes as well. So this is a really good example to demonstrate the concept of interfaces, abstract classes, and concrete classes. So here in this hierarchy, at the top of the hierarchy, we have the collection interface, and with the interfaces we have just abstract methods, and these methods will be used by all of the sub classes and sub abstract classes or interfaces. So here it is the concept of interfaces and how to connect one interface to the other. So at the top, the collection, as we mentioned, will be the contract that every subclass will be followed. The collection has many operations that we can use and implement in the subclasses and sub-interfaces. And here we have, in this hierarchy, again, we have the set interface, list interface, and queue. All of these are interfaces, and they are not ready to be used. We have to implement the abstract methods, and this will be done in partially in the abstract classes, as we can see, and then we will complete the implementation of the missing or the abstract methods in the concrete classes, as you can see here. So let's take this path. We have at the top of this hierarchy, we have collection. Underneath, we have the list interface. Part of the abstract method will be implemented by the abstract list. And then we have concrete classes like the array list and the stack, vector. All of these are just kind of concrete classes that are ready to be used, and we can use them later on. So let's start doing some hands-on, and let's start working on a new project. Okay, so again, the collection interface defines the common operations for the list, stacks, queues, and other data structures. The Java collection framework support two types of containers. It support the collections or collection and the map. The map is a data structure that stores key value pairs, and we can search by the key, and this will be beyond of our um, lecture. Now let's start using the lists and the collection. So the collection, as you saw in the previous slide, is an interface. So this interface cannot be uh, used to create a new object, but here I'll declare um, a list. It's a type of an array list, and this is the array list. So the list can be initialized in different ways, either just adding some elements, and this operation, the add, is one of the methods that we can see in the collection interface, and this is implemented in the array list class. So as we mentioned, that the collection interface defines the common operation. So this is one of the common operation. The add is one of the common operation that we can see in every subclass of the hierarchy that we just introduced you to. So this is one of the things to add the items that you want, and let's say that add again, and here we can add another number and so on. Or we can do like this. So here I'll start by creating an array, a regular array, AR equals, and I can initialize the array with some numbers. I have some duplicate numbers here, as you can see. And then I can create another collection, another list, and here I can use the constructor to initialize this array list or list one. So I will pass the array elements to this list. So this one, I am converting the array into an array list, and then to initialize the list one. And here there is no need for those. So now I have both ways, two ways to fill the array list with some elements. Okay. Now let's print the arrays and to see the output so far. So I can say this is the output of list. And I repeat this one again to show you list 2. Now run. I have list 1. Sorry, again. Yes. So look at this. This is the first list that I added at the top here, and then the second list, list 1, that is initialized with the array that we just mentioned. Okay, so this is the new list. Now, if you notice that this array or this list has some duplicate elements like the 3, 5, and maybe others. So I'll share with you this interesting thing to get rid of the duplicate elements without doing more efforts or without doing your own code. So um, I'll use another data structure based on the hierarchy that I introduced you to. We have the set, as you remember, and here is another set. And the set, as you know, it's an interface, which is a sub-interface of the collection interface. So we have the same properties in addition to some new properties, I mean new methods. So one of the methods that is shared by all the sub-interfaces or sub-classes of the collection is the add, as you know. So the set is an interface, and we cannot use it right away. So we have a concrete class named hash set. See this one? A hash set is a concrete one, and let me pass the previous list one, to this new set. Okay, so I'm initializing the new set, the hash set. This is a concrete class, and I am initializing it with the list that we talked about, and now we will do just printing the new set. So let me type set, and let's see the output now. Look at this. What's the difference between this original list that we entered, we initialized the set with, and the output here? So to make it more clear, let me print the size of list1 dot size. See this one? So here I'll add list1 size, and I'll do the same thing for the set, and we called it the set size. And let's run it again. So the size of this original list is 10, and after we passing it to the set object, we get 8. Can you tell what's the difference? So here, look at this. It's very interesting. This set is a set that contains no duplicates, no duplicate elements. So it's get rid of any duplicate element. So if you want in the future to write a list without duplicate element, so use the hash set. Use this set example to get rid of anything. So there is no effort and no more instruction. All what I did is creating a new hash set and initialize it with the list that you have, the list that has maybe has some duplicate elements, and that's it. You are good to go. Okay. So in the next video, I'll show you how to work on the collections class and how to do some operations on the data structures. So again, the collection has some data structures like set. The set is a data structure that stores a group of non-duplicate elements. The list stores an ordered collection of elements, and we have the stack and queue that we will talk about in the next video. Thank you. I hope you enjoyed this video. Please subscribe to my channel, and if you like it, just do thumbs up. Thank you and goodbye.